In this episode, we start looking at asset management as a security practice, not just an administrative inventory task. An asset is anything the organization uses, depends on, stores, processes, connects, or must protect. That can include laptops, servers, phones, applications, cloud services, databases, documents, storage locations, network devices, and data sets. When security teams do not know what exists, they cannot protect it consistently. They may miss patches, overlook unsupported software, fail to monitor critical systems, ignore sensitive data, or leave old devices connected long after they should have been retired. Asset management gives the organization a clear picture of what it has and what condition those assets are in. You can think of it as the foundation under many other security tasks. Before you can defend the environment well, you need to know what is in the environment, who owns it, where it is, and why it matters. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at CyberAuthor.me in the Bare Metal Study Guide series. Hardware asset management focuses on physical and virtual devices that support the organization's work. This can include desktops, laptops, mobile devices, servers, routers, switches, firewalls, printers, storage systems, security cameras, badge readers, point-of-sale devices, and specialized operational equipment. Virtual machines and cloud-based compute resources may not be physical boxes in the office, but they still act like hardware assets from a management point of view. Each one needs ownership, configuration, patching, monitoring, and eventual retirement. Hardware inventory should capture more than a device name. It may include serial number, location, assigned user, business purpose, operating system, network address, warranty status, support status, and security tool coverage. That information helps security teams answer practical questions quickly. Which systems are exposed? Which devices are missing protection? Which laptops are assigned to which users? Which servers support critical business functions? Software asset management focuses on the applications, operating systems, libraries, platforms, and services used by the organization. Software can be installed on endpoints, hosted on servers, delivered through cloud platforms, embedded in devices, or accessed through a browser. The organization needs to know what software is running because software creates both business value and security exposure. An outdated application may contain known vulnerabilities. An unapproved browser extension may collect sensitive data. A forgotten test application may still be reachable from the internet. A cloud subscription may store business records without the security team knowing it exists. Software inventory also helps with licensing, cost control, vendor support, and compliance. From a security perspective, the main concern is visibility. If you do not know an application is present, you cannot patch it, assess it, monitor it, restrict it, or decide whether it should still be allowed. Data is also an asset, even though it is easy to overlook because it does not always feel like a device or application. Data assets can include customer records, employee files, payment information, contracts, source code, research, intellectual property, system logs, email archives, backups, reports, images, and business analytics. Data may be more valuable than the systems that store it. A laptop can be replaced, but the sensitive data on that laptop may create legal, financial, privacy, and trust consequences if exposed. Data asset management asks where data is created, where it is stored, who can access it, how it is classified, how long it is retained, and how it is disposed of. This connects directly to data protection because classification and inventory guide the controls. Confidential data may need encryption, access review, retention limits, monitoring, and strict disposal. Public data may need fewer controls. The asset lifecycle describes the full path an asset follows from planning through retirement. For hardware, that may begin with identifying a business need, purchasing a device, assigning it to a person or team, configuring it securely, using it, maintaining it, tracking it, and eventually disposing of it. For software, the life cycle may include selection, approval, licensing, deployment, updates, monitoring, renewal, replacement, and removal. For data, The life cycle may include creation, classification, storage, use, sharing, retention, archival, and disposal. Life cycle thinking matters because risks change over time. A new laptop may be secure when issued but risky later if patches fail, the user leaves, or the device is lost. A useful application may become risky when the vendor stops supporting it. A dataset may become unnecessary but still dangerous if it remains stored forever. Asset management keeps attention on the full lifespan, not only the first day. Ownership is one of the most practical parts of asset management. Every important asset should have someone responsible for it. That does not always mean one person personally fixes every issue, but someone should be accountable for decisions about the asset. A system owner may decide how critical an application is, who should use it, and when downtime is acceptable. A device owner may be responsible for returning equipment when leaving a role. A data owner may decide classification and access expectations. Without ownership, problems drift. A vulnerability scanner may find an exposed server, but no one knows who approves downtime for patching. A storage location may contain sensitive files, but no one knows who can decide whether they should be kept. Clear ownership turns security findings into action. It gives teams a path for approvals, risk decisions, maintenance, decommissioning, and incident response. Accurate inventories are essential for patching because patching starts with knowing what needs to be updated. A security team may receive notice of a serious operating system flaw, but it cannot respond well unless it knows which systems run that operating system. A vendor may announce an application vulnerability, but the organization needs to know where that application is installed. A network device may require a firmware update, but unmanaged devices can be missed. Incomplete inventory creates blind spots. Those blind spots are dangerous because attackers often look for exactly that kind of forgotten system. A patch program built on poor asset data will always leave gaps. Good inventory helps teams prioritize patches by asset criticality, exposure, and sensitivity. An internet-facing server that handles customer logins may need faster action than an isolated test system. Asset management gives patching the context it needs. Asset management also supports monitoring because security teams need to know what normal looks like for the assets they protect. A monitored server should have an expected role, owner, network location, software stack, and communication pattern. If a database server suddenly starts connecting to an unusual external destination, that may be suspicious. If an unknown device appears on the network, that may require investigation. If a critical system stops sending logs, the team needs to notice. Monitoring is much weaker when the organization cannot distinguish approved assets from unknown ones. An accurate inventory helps security tools classify events, reduce confusion, and prioritize alerts. It also helps incident responders during investigations. When an alert appears, responders need to know what the asset is, who uses it, what data it handles, whether it is critical, and what other systems depend on it. Classification is another reason asset management matters. Not every asset has the same value, sensitivity, or risk. A public marketing website, a payroll database, a development laptop, a domain controller, a training system, and a backup repository should not all be treated identically. Classification helps the organization decide which assets need stronger protection. Hardware may be classified by business criticality, location, exposure, or operational role. Software may be classified by sensitivity, vendor support status, internet exposure, or dependency importance. Data may be classified as public, internal, confidential, restricted, regulated, or another category used by the organization. The exact labels can vary, but the purpose is the same. Classification turns a flat list into a meaningful security picture. It helps you understand which assets need the strongest controls, fastest response, most careful access review, and most disciplined disposal. Unknown assets create some of the hardest security problems because they sit outside normal management. Shadow information technology, IT, happens when teams use systems, applications, devices, or cloud services without going through approved channels. Sometimes this happens because people are trying to work faster, not because they are trying to be careless. A team may sign up for an online tool to share files, build a quick database, or test a service. The risk is that sensitive data may end up in a place with weak access control, poor logging, unclear ownership, or no retention plan. Unknown hardware creates similar risk. An unmanaged device may be missing patches, security software, encryption, or proper configuration. Asset discovery, network scanning, cloud account review, procurement coordination, and user education can help reduce these blind spots. Security teams cannot protect what remains invisible. Asset records should be maintained, not treated as a one-time project. Environments change constantly. Employees join, change roles, and leave. Devices are purchased, reassigned, repaired, lost, and retired. Applications are installed, updated, replaced, and abandoned. Cloud resources can be created quickly and forgotten just as quickly. Data sets are copied, exported, archived, and moved to new platforms. If the inventory is not updated, it slowly becomes less trustworthy. A stale inventory can be worse than no inventory because it gives people false confidence. The organization may believe all systems are patched because the inventory says so, while several new systems are missing from the list. Good asset management uses processes that update records during procurement, deployment, change management, monitoring, access review, and decommissioning. The goal is not perfect paperwork. The goal is a living source of truth that supports security decisions. Decommissioning is the process of removing an asset from service in a controlled way. This is a major security concern because old assets are often forgotten, but forgotten does not mean harmless. A retired server may still contain data. An old laptop may still have cache credentials. A cloud storage bucket may still be accessible. A test application may still have a public address. An expired software license may still be installed and unsupported. Decommissioning should remove access, preserve records when required, transfer or delete data properly, revoke credentials, update inventory, remove network connections, recover hardware, and confirm that the asset is no longer active. For data assets, decommissioning may include archival, retention review, secure deletion, or legal hold checks. A clean decommissioning process reduces the number of abandoned systems and data stores that attackers can find later. Asset management also supports compliance and audit readiness. Many security and privacy requirements depend on being able to show what assets exist, what data they handle, who has access, and how they are protected. An auditor may ask for a list of systems and scope for a regulation. A privacy team may need to know which applications store personal data. A vulnerability management team may need to show that critical assets are scanned and remediated. A records team may need to prove that data is retained and disposed of according to policy. Without asset management, these requests become painful and unreliable. With strong asset records, the organization can answer with more confidence. Compliance is not the only reason to manage assets, but compliance pressure often reveals whether the asset program is mature enough to support real accountability. For Security Plus questions, listen for whether the scenario is asking about visibility, ownership, classification, patching, monitoring, or retirement. If the organization does not know which systems it has, the answer may point toward asset inventory or asset discovery. If it cannot patch effectively because it does not know where vulnerable software is installed, asset management is part of the solution. If it cannot prioritize findings, asset criticality and classification may be missing. If old devices or applications remain active after they are no longer needed, decommissioning is likely involved. If data is not protected properly because no one knows where it lives, data asset management and classification matter. The exam may describe asset management in practical terms rather than using the exact phrase. Your job is to recognize that accurate asset information supports many other security operations. The larger lesson is that asset management is the map security teams use to protect the organization. Hardware assets need to be known, assigned, configured, monitored, maintained, and retired. Software assets need to be approved, patched, licensed, watched, and removed when they are no longer safe or needed. Data assets need to be located, classified, protected, retained, and disposed of according to their sensitivity and purpose. Accurate inventories make patching more complete, monitoring more meaningful, classification more useful, and decommissioning safer. Weak asset management creates blind spots where risk can grow quietly. Strong asset management gives the organization a clearer view of what it depends on and what it must protect. When you understand asset management this way, it stops feeling like a spreadsheet exercise and becomes one of the foundations of practical security operations.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.